And good afternoon, ladies and gentlemen. My name is Alaa, and I am a fan of smart cities. I read a lot about them, I think a lot about them, and I think they are the most interesting topic in the world. And I hope that by end of this presentation, I'll be able to pass some of that excitement to you. As Richard said in his opening notes, we are here to learn, to inform, and to inspire. And this is a high bar that I hope I will clear today. Let's start by defining what a smart city is. You will find plenty of definitions out there on the web, but this is my favorite one. By Boyd Cohen, a technology strategist. He says that a smart city is a city that utilizes ICT tools to achieve two goals. Number one, making the citizens happy by providing them more services and increasing their quality of life. Number two, it's reducing our carbon footprint and overall environmental footprint. What I like about this definition is it does not put technology at the center. It puts humans at the center, and it puts environments at the center. And this is our first key message here today, that a smart city is not one that is a showcase for technology. Rather, it's one that is enabled and empowered by technology. And this is very relevant to us here because we live in one of the most exciting parts of the world. We're surrounded by mega cities and mega projects who want to be smart. From the Expo 2020 in UAE, to NEOM and the Red Sea project in Saudi Arabia, to the Lusail city in Qatar. All of these are embarking on a transformative journey to transform their cities from regular cities to smart cities. How they're doing that? By engaging in a process of digital transformation that has 6 blocks: Internet of Things, security, both physical and cyber, AI and machine learning, big data and analytics, 5G mobile computing, and blockchain. Today, because time is short, we're gonna only focus on 2 out of these 6 components: security and Internet of Things. Let's start. When we talk security in smart cities, it's important to remember that it's not about the number of cameras, and it's not about how much footage you collect. It's about the intelligent analytics that you run on top of this footage so that you can have historical analytics, real-time analytics, and more importantly, predictive analytics. This is how you transform data from raw data into actionable data. Let's take some examples. In Abu Dhabi, the traffic police is experimenting with mobile edge computing with intelligent analytics. We're all familiar with license plate recognition at the entrance of parkings or malls at 0 kilometers per hour, but that's boring. What if we do license plate recognition and intelligent analytics at 120 or 150 kilometers per hour? What they're doing here is they're installing mobile edge computing with intelligent analytics at the edge to capture all the license plates of all cars driving at average of 120 kilometers per hour across 12 lanes in 2 directions. And they're deciding real time who the violators are. This car is speeding, this car's registration is expired, this guy is not wearing a seatbelt. Obviously, this requires a lot of heavy GPU computing at the edge, but more importantly, intelligent software analytics at the edge, also linked to the cloud with currently 4G technology, and 5G technology is coming on the way. Dubai police upped the ante. So instead of doing a fixed monitoring of mobile targets, now they want to do mobile monitoring and analytics of mobile targets. So in the last Intersec before the pandemic, they showcased a police light bar with 12 cameras with a mobile edge computing in the truck that is doing analytics of these license plates and issuing the traffic violation on the move as both the target cars are moving and the police car is moving. The next step is they want to send some of that analytics into the cloud. They're just waiting to experiment with 5G gateways so that they can move a lot of this analytics to the cloud and save it from the car itself. Let's apply some more intelligence to it. In Japan and in Taipei, you have two companies, Fujitsu and A-Value, who are applying AI and machine learning to analyze traffic patterns. And this is enabling them to come up with intelligent insights to know how to design the traffic patterns and design the urban planning as a result. Here in Dubai, there's an MIT spin-off co-founded by very clever Emirati and American people who is applying AI technology to V2X communications, which is vehicle to everything communication. What they're doing is they're monitoring with their smart, intelligent video analytics the pedestrian movement at the intersections of crosswalk. And their machine learning model is able to predict from the movement of the person and from his body language whether he's distracted or focused as he approaches the intersection. And by that, the system is able to send immediately a warning to drivers in cars approaching that crosswalk to slow down. Technology can save life. And as Arif said in his speech, this is what's called preventative soft security. This is what we want, right? This example talks about how this security can be productized and monetized. In Saudi Arabia, STC, the telecom operator, bundled together cameras, mobile edge computing, analytics at the edge, connectivity, and analytics at the cloud, and offer it as a video surveillance as a service package to SMEs, lowering their barrier of entry. So now, instead of having to spend tens of thousands of dollars to have security, you can spend 30 or 40 riyals per camera per month and have the entire package with its maintenance. This is an important example, especially for telcos, service providers, and system integrators, because it solves the problem that Engineer Arif and Dr. Al-Katbi were talking about, which is monetizing security and monetizing technology. Now, those developers, those master urban planners, those smart city operators can have a way to recoup their investment on heavy security equipment by selling it as a service. Yeah? Technology changes business models. But enough of security, let's talk about the Internet of Things. What is the Internet of Things? If you Google Internet of Things, you will get north of 5 billion results. So it's #trending. And that's why it's very important to all of us, technology fans, to educate ourselves about it, about its business models, and about its application. You will find a lot of definitions of IoT. My favorite one is IoT is the third stage of the internet. The first stage of the internet was obviously in the early 90s, where the internet was simply a bunch of computers connected. And then in the early 2000s, we started adding smart devices like our phones and tablets. And then the internet moved from phase 1, internet of PCs, to phase 2, which is internet of smart devices. But what happens next? What if we start adding everything else and connecting it to the internet? What if we start connecting power substations and street lights and roads and bridges and buildings and trucks and trees? When you connect these non-smart devices to the internet moves from stage 2 to stage 3, which is Internet of Things. Now, the simplest solution architecture of an IoT is things connected to the cloud. What are these things? They could be sensors, such as a soil sensor connected to the cloud and sharing data about humidity, temperature, and acidity. Or a fuel tank sensor that is sharing data about temperature, leak, and fuel level. But these things can also be machines. Think, for example, of a power substation that is sharing data from sensors about voltage, current, fuel level, and temperature. Or a moving machine like a truck equipped with dozens of sensors and sharing all the data you need about location, speed, tire pressure, and other telematics data. Why are we doing this? We're doing this because on the other side of the cloud, we have a data center where people are sitting in front of screens, receiving all this avalanche of data and applying to them intelligent analytics, historical analytics, real-time analytics, and predictive analytics. And this is enabling them to make smart decisions and actionable decisions based on this data. Again, the message is the same. It's not about collecting data. It's about what you do with this data. If you ask any research company about the growth of IoT, you will hear different numbers. If you ask Strategy Analytics or Gartner or Cisco or anyone, you will hear some estimations of 30 billion, 40 billion, sometimes 50 billion devices will be connected to the internet by 2025. But even though they disagree on the total number, they all agree that IoT or non-smart devices or things will take the lion's share of the internet. So for every mobile or tablet or PC, you will have 6 or 7 things. The ratio will be 6:1 or 7:1, and the face of the internet will change, and the meaning of what it means to say internet will change. So my favorite part of this discussion is inviting you to join me in a journey around the globe to see IoT in action. From Dubai to Dublin, from Chicago to Sydney, from Riyadh to Sao Paulo, let us see how IoT is changing industries and changing business models. Let's start with Abu Dhabi. ADDC is connecting thousands of their power stations using IoT gateways and IoT sensors, sending data to the cloud about everything from voltage, current, to fuel level, to temperature and intrusion and security information, and analyzing all of these in the control center to decide on preventive maintenance or reactive maintenance. Smart meters, whether it's electricity, water, or gas meters, they are meters equipped with IoT radios, such as LoRa or NB-IoT, and connected to the cloud. What they do is they enable the consumer to monitor his consumption on a smart device. But more importantly, they enable the utility company to plan the demand, to study the demand, and study the peak times and analyze it and plan their supply accordingly. Just before the pandemic, the global penetration of smart metering was 14%, and we in this part of the world are very well involved in this trend. In Riyadh, there's a project for 10 million smart meters, and in Abu Dhabi, there's a project for 2.5 million meters. Let's talk about routes. In Dubai, the RTA has been involved for the past 5 years in equipping all traffic signals on the intersections with IoT sensors and IoT gateway to monitor the intersection, but to also monitor the equipment itself. In Sydney, they're taking this one step further by installing an adaptive traffic information system. And this system, opposite to what's used in most parts of the world, does not use a timer to decide whether this way should be green or this way should be red. Instead, it uses intelligent cameras, traffic pattern analytics, and opens and closes the different roads of an intersection based on the heaviness of traffic on each side. This is clever. The same is being done in Dublin, which has been measured to reduce travel time by 20%, waiting time at the intersections by 40%, and reducing our carbon footprint by 20%. The same is being deployed all across the world, from London to Sao Paulo and other places. Let's talk about Internet of Parkings. In Barcelona, the city has installed smart IoT sensors in public parking spaces. These sensors have IoT radios in them that talk to the cloud and only relay one information: the parking is empty or the parking is full. This data is collected from tens of thousands of sensors across the city, and the municipality is able to analyze and decide where they should add more parkings based on demand. But more importantly, it's allowing citizens and visitors to use a simple app they download on their phone to find the closest available parking instead of losing time. The same is being tested and implemented in Dubai Design District, or D3, just around the corner. What you see on the right-hand side is a monitoring station on the top of Jabal Hafit in Alaa. And this is equipped with cameras and IoT gateways and a weather station, and monitoring the formation of clouds in the sky, running them through an analytics software and deciding the precision time of when should they do cloud seeding. Internet of Clouds, Internet of Things. This is an IoT node under a bridge in Chicago, connected to vibration sensors and correlating the vibration pattern of the bridge with traffic patterns, morning versus evening, weekends versus weekdays, and rush hours versus normal hours. This data is being relayed and analyzed to the city of Chicago, where they use it to decide real-time decisions, for example, divert the traffic of this bridge, or long-term decision, for example, this bridge should never be used by trucks. This is an IoT node in the northeastern part of the United States, measuring the temperature on the road and the thickness of the ice, and being used to send back to the control center so that they can warn the drivers over digital signage about which roads to avoid. This example is close to my heart because it comes from my country, from Lebanon, where a very clever entrepreneur has started her own startup called Internet of Trees. And what she's doing is she's using intelligent video analytics over cameras to analyze the health of fruit trees, to monitor and identify the different pests, and to recommend to farmers what kind of pest they should use and with what precision quantity. Even trees are being connected to the internet. Now, what I left till the end is my favorite example of all of this. I visited Galway in Ireland in 2015, and I met a small business that does ready-made concrete. It's run by Des, the father, and his son, John, who is the new blood running the business. Now, what I learned by discussing with them is I learned a lot about the concrete making business. Basically, you pour the liquid cement into these molds, and then you have to wait until the concrete cures. You don't want to remove the mold too soon because the concrete could crack. But also, you don't want to leave it too long because you're losing storage time, project time, time to market, and money. So you have to strike just the right balance. After being in the market for more than 40 years, Des, the father, who's a 67-year-old, very pleasant man, he was able to identify the exact amount of time needed for the concrete to cure based on the time of the year, based on the temperature and the humidity outside. And he's done it for 40 years, and he has the tribal knowledge, and he's the expert on it. The problem is in 2013, the EU introduced new regulations to cement, and they mandated that every bag of cement should have between 15 and 30% of human waste. This changed everything. And now these concrete blocks, some of them took 28 hours to cure and some took 40 hours to cure. And the data was all over the place. So to be safe, Des's company started leaving all concrete blocks for 48 hours just to be on the safe side. And then they started losing money, and they started delaying project, and they started losing business. So John, the young son, who was dabbling with IoT at that time, thought about using IoT to solve this problem. He installed IoT nodes on each one of these blocks and connected them with two thermocouples. A thermocouple is a temperature sensor that costs €1. It's expendable, and it does not need electricity. They planted the two sensors inside the liquid cement. They connected to the IoT node, and they monitored the temperature over the cloud. So if you go and visit their factory now, you will see dozens of rows and dozens of columns of concrete blocks left to cure. And on each one, you will see one IoT node connected to two sensors. The IoT nodes in hundreds form a mesh, and they talk to a gateway, and the gateway sends data to the cloud. And on the corner of the yard, you will see John sitting with his laptop open, browsing through the different pages on an application that he made that shows the different rows or different columns of these blocks. For example, in this case, you can see that the first 5 blocks still have some time to go, but this block is ready. There is no arguing with data, right? So they remove the mold, they disconnect the IoT node, they sacrifice the two thermocouples, and they ship the block to site. What I will never forget is what Des told me when he was explaining this business case to me. He said it was like the data, it was like the concrete was talking to us. This is the power of data and technology. So let's wrap up. Today we spoke about Internet of Stations, Internet of Meters, Internet of Traffic Signals and Intersections, Internet of Parkings. We spoke about Internet of Roads and Bridges, Internet of Heavy Machineries and Cement and Concrete Block. And because we're short on time, I could not talk to you about many other things. Internet of Oil Pipelines, Internet of Trash, Internet of ATMs and vending machines and coffee machines, Internet of vine trees. This is how IoT deserves its name by becoming Internet of Everything. I will finish with 3 messages, one for the business leaders, one for the service providers, and one for the city leaders. For the business leaders, whether you are in the light industry, such as retail, banking, or healthcare, or in the heavy industry, such as transportation, utilities, oil and gas, and others, embrace digital transformation. Digital transformation can solve your existing problems and transform your business into more efficient, less OpEx, and sometimes new revenue streams. To telcos, service providers, and SIs, You can no longer be satisfied and stick with selling connectivity, cloud, and licenses. These are being commoditized. The next step to remain competitive is to move up the value stack and find a way to productize IoT, security, analytics, and the other 6 pillars of digital transformation. And this is how you will survive the next disruptive phase. And for our city leaders and governments, I would say digital transformation is not an option. Smart cities is no longer a buzzword. It's a mandatory process that every city must engage in if it wishes to compete in the new economy of the 21st century. Thank you for your attention.